Number 6. Several students are going to ride their bikes from the city park to Lake Kagansa, a distance of 25 miles. They will ride at an average rate of 10 miles per hour. What is the latest time they can leave the park in order to arrive at the lake by 11 a.m.? Now, just a rule of thumb for me, when I used to teach math every day, I would always tell my students, if someone or something is moving, draw a picture. And I do that whether you guys are watching or not. So I'm going to stay true to my habit. This is a fixed point where we have the lake. Okay, that's getting to me now. The lake is on this side. So this is the Lake Kingonsa, and this is the park. So I'm just going to use the letter P. And we know that this distance is 25 miles. And riding at 10 miles an hour, that means that in 1 hour, they could cover 10 miles. This is 1 hour. And then in another hour, they would do another 10 miles. That's 20 miles. That's 1 hour. And then that last 5 miles, pretend this is to scale, is not going to take a whole hour. It's only going to take a half an hour. Because they're riding at 10 miles an hour, the trip will take 2.5 hours. So I'm already in good shape here. If they want to arrive at the lake at 11 o'clock a.m., what time do they have to leave the park? So you can subtract the time is the easiest way. But if that bothers you, and I'll do that in just a minute, let's count backwards. Let's say, okay, this was half an hour, so that would put them at this point at 10:30. Then we have this one being an hour, so that would put them at this point at 9:30. And then taking off another hour, they would have to leave at 8:30. So that's a visual of how to do this. You can also simply say 11 hours, 11 o'clock, minus 2 hours and 30 minutes. Now to do that, you will have to borrow an hour and make it 60 minutes. So that would be 30 minutes and 8 here. That really bothers some folks. So if that bothers you, don't do it. Use the diagram and count your way back.